All right, so we're going to talk about two frameworks that run React code on both the client and the server. They're called Remix.run and Next.js. And we'll talk a little bit at the end towards the end of the talk about React 18. Again, I am Ken Rimple. This is me jumping off of something when I heard that there was another React framework. I couldn't take it anymore. So I've been teaching for almost off and on for almost 30 years and training and consulting and doing software engineering. I've seen a lot of tools come and go, a lot of them. So I don't get too enamored of any one thing because I know within 3 to 4 years, the world pivots and changes. It's a life of constant learning. I'm a musician and father of 4. Sorry about the interstitial 2-chord thing. That was me. And I wrestle JS to the ground these days, and then it comes up and hits me the lawn chair when I get up and walk away. All right, so attendee assumptions. We're assuming for this talk that you know some of this stuff because it's just going to help you to look at the code. First of all, you should know React. Specifically, you should know functional React. And functional React is writing React components with functions. Also, because you're doing that, you should know your hooks. Hooks are the functions that you run to create side effects, like setting state or responding to the loading of a component or the update of a proper component with an effect. So if you know that, you're in good shape. You should know how to deal with promises, at least with a then function, which almost everyone doing any JavaScript that does anything significant is going to know. But in case you don't, you brush up on this and watch the talk later. And most people these days are using async and await to do promises, and you'll see that code. So I'll show you a few of those things. And experience using React and client-side APIs to fetch data. Some of that is great. Some of it, as Jack had said earlier, can be thorny and filled with performance issues and question marks. So as things get complex, you've got, Axios, async await, asteroids, whatever, or alien invaders, you have to adjust and try to optimize your code. So if you've done everything with like plain old create React app and you've, done vanilla React, then you might run into some things that make you think there probably need to be some optimizations you could take. So did any of these scenarios happen to fit you? One of them is that you have a lot of static content, or at least close to static, meaning that it's updated lightly throughout the week, the day, whatever, but you need React on top of it for dynamic application manipulation. So if you have that need, some of these things we talk about today can help you. Is your existing application sluggish? Does it take a long time to load it? Do you have issues when it does load about getting to that time of interaction where you can actually do something by typing into something or scroll or go somewhere else? Is it just hanging there? Is it complex during the loading process? Are you building a monolith in React? And I've seen them. You can have React apps that are huge. Not always a good plan. Breaking those monoliths up a little bit into smaller chunks can help. And things like Next and Remix can help you with that. Do you have your users on slower networks? Maybe they're distributed across the globe, and maybe some of them have slower phones, and they have high latency to get the content. So they can't really afford a 4 meg download of the beginning of your application necessarily, or more, because you've got a giant Webpack build that takes a long time to load, or it takes a long time to get data back and forth. So how can we optimize that channel? Maybe some of these tools can help with that. One thing you want to keep in mind is that Google spent a lot of time researching things like bouncing off of pages. If you look at Google's analytics, one of the things is bounce rate. A bounce rate is how many times someone goes to a website and then leaves, doesn't come back to the next page. And that's a bad statistic to have as a high number. So one of the research statistics is that the probability of bounce for mobile applications increases 32% as page load time goes from 1 second to 3 seconds. That's significant. There's a link right there at the bottom where you can see the source for that. There are a number of these stats that Google's put over the time. They're looking for ways for you to optimize your network fetching, limit the number of bytes you're sending across, and how quickly you can start things up in order for you to be proficient. So you want to look at Google's page speed plugins and their performance team and learn from them about recommendations of speeding up React applications. Well, these two platforms today we're going to discuss actually try to do that. So they are server rendered and server generated React code frameworks, Next.js and Remix.run. let's talk about each of them in turn a little bit, just kind of introduce you to them. So Next.js, which I will show you here, is a product created by Vercel. It's an open source framework, and Vercel is a edge hosting provider. So they set up applications to run across the internet, and they can target them to run in edge server networks close to you. And so Vercel grew out of the Next.js project and now is a hosting provider. I believe they use AWS behind the scenes, but don't quote me on that. The project's almost 8 years old and has many contributors. It's well-funded, and it was created by two people, Guillermo Rauch and Tim Newkins. And Guillermo actually spoke at ETE in 2017. In fact, if you go to youtube.com/ChariotSolutions and look up our ETE playlist, you'll find his talk on Next.js way back in 2017, 5 years ago. It's got 17,000 forks and 84,000 stars, and version 12.1 was recently released. So that's definitely a mature platform with a number of releases. So things it features: server-side rendering. So what this means is you can hit a URL, and that URL will server render React components, ship them down pre-rendered, and then boot a React application around them. That's called server-side rendering. At request time, something runs code and then renders components to ship down to the browser for a quick startup. So that's one of the first things they put together. One of the first things they put together in Next.js was server-side rendering. They also have a concept called static site generation, which if you've worked with any of the, oh boy, having a hard time with this now, Jamstack things like Gatsby, static site generation is a pretty common thing that you see out there as a way of optimizing rendering of static content like web pages and things like that. Well, Next.js also has static site generation. They will run a function, and then they will take the output of that function and run React component renders for shared content, and then store that for use at runtime. So it's built, stored, and served like static content that then ultimately boots up and becomes part of your React application. So if you have catalogs and blogs and things like that that you want to generate from source on a database, but you only have to do it at build time, and maybe you update a few of them periodically, static site generation could be a thing you could use. They also have an addition to that called incremental static regeneration. And the idea behind that is you start out with generated static URL paths that are pre-generated. And when you hit one that is stale, where you've determined what the stale factor is, how long it's been there, for example, or if you've marked it as invalid, it will just do server-side generation, server-side rendering at request time for that, and then cache it again. So you can statically generate your site and then punch into it and update things periodically. They also have a library called SWR, which we'll talk about a little later, which once the app is loaded, kind of functions like a smart fetch or Axios query library for client caching, and it knows how to reload data based on age or based on moving, navigating from place to place and hiding your view. So that's another project that they have in Next.js. And they also have this routing mechanism. All larger React applications generally use a router to switch between main components, or like if you have a main pane and like a master detail or whatever, they use routing. Well, Next has a router based on files that is based, I believe, on the React router, but I can't verify that at the moment. And it supports server-side routing. The idea being, if you hit it from the browser and it's the first thing you hit, it does whatever it needs to do to download it, and then it loads the rest of React in the background. So then your next route is just hitting that page's content. You can see it has a pretty active version history. If you just look at the last couple, they did things like in Next.js 9, they started gzipping their responses, which is a nice optimization. By the way, these run on Node.js, both these frameworks we're talking about. So this is the Node.js engine. And so it's running and outputting gzipped content by default that even speeds up your content download more. They have static site regeneration, server-side regeneration and static site generation added in 9. Then 10, they added an image tag, which we'll talk about a little bit later, to optimize image display and let you import CSS at the component level as modules. Next 11 added dynamic asynchronous script loading after the app is loaded for things like analytics. So you're not waiting for the page to render because your analytics aren't there yet, for example, and a fast refresh. So lots of things have been going on with this tool. Also in Next 12, they started adding things like a fast build tool called SWC, which is a Rust-based build tool to really speedily generate your content. Remix.run is the alternative that we're talking about today. It's a newer one. We are heading to the Remix conference, a couple of us at Chariot. It's got a lot of buzz. Drew DeCarm, for example, who spoke about creating your CSS from scratch yesterday, really likes it. It's an alternative server-side rendering platform. So it's relatively new. It's about 2 years old. And it's got 14,000 stars and about 300 contributors. And version 1.3.3 was recently released. So that tells you one thing about the comparison between the two is that Remix is the newcomer. It's kind of the up and coming, and it's rushing down the road to add features and get things mature. And they're still working through some things. One of the areas they're working through a lot is some of the CSS frameworks that are hard to support when you use server-side rendering. So they're working through some of those issues. So some things are, some things aren't supported. But it's pretty good. And their philosophy is similar, but they also are pushing this concept of focus on HTTP-based standards. So what does that mean? Well, because I mentioned before that there are Node.js services, when you run a React component in Remix, they use the web fetching APIs. So for example, the fetch function is the same fetch function you'd find in a client-side React component, and the request and the response and the URL parameters and everything else are all the standard APIs. So they really pushed standards as much as they could. Their goal is to not wrap everything and to try to just use standardized things where possible. They also have a file-based router. It's very similar to the way Next.js does theirs, and we'll compare the two. It's literally brackets versus a $sign for dynamic paths. And beyond that, they work very similar. Remix also supports progressive enhancement of your application as you start with maybe JavaScript disabled, which is kind of a rarity today, but some people might. So for example, if you disable JavaScript, the forms you use based on Remix's forms library can be completely server-driven so that you don't have to run JavaScript on the client. And maybe that's good for an app that has a lot of server-rendered stuff and a lot of content, but then you have to input a few forms, and you want everyone to be able to do it, even if they don't have JavaScript. So the forms at least can work. Their philosophy is, and this is on their website on a page called Philosophy, embrace the client-server model, including separation of source code from the content and the data. So they really make a hard break between the two. If you look at their requests and responses, there's not a lot of shipping of plain old static, completely unrendered content or unhydrated content. So it's a little bit different. Working with, not against, the foundations of the web, browsers, HTTP and HTML. One of the things that I'll mention now is instead of static site generation, they recommend that you cache your responses from your servers because they say use the standards on the web. So that's why they kind of oppose static site generation for file-based build time. And then use JavaScript to augment the user experience by emulating the browser behavior, as I mentioned before, and don't over-abstract. Now let's look at how client fetching normally works with a React application. So let me see here. I'm just going to go in and look at a standard, plain old React-only example. So we're going to look at an app that's put together to kind of abuse the web a little bit and make it hurt in terms of performance. So this is just basically going through a bunch of podcasts that I have on my OPML XML file that they store for podcasts. So it gives all the podcast addresses. And then for all the shows in the podcast, I basically used a Node app to crawl all the podcasts from that file, insert them into a Postgres database, and then have another table for each of the episodes so that I could just render a lot of content. If I click on any one given thing in here, I'm looking at the actual, well, maybe I'm not. There we go. I'm looking at a given podcast. Okay, so this is a 2-page route. If we look at just the plain old React client, just being served as a client, and we load this thing up, you'll notice that what it does is it goes ahead and it fetches the main page. There's my localhost page, and it's just literally the HTML shell. And I just want to bring this up a little higher. There we go. So there's my HTML content. It's got the script that's been built with Webpack. And then that gets downloaded, and we start loading things. So for example, the bundle React Dev Tools, that's turned on. I do have that turned on. And now we're at the point where we've got the data loaded, or sorry, the shell loaded, and we start fetching things like our Ajax content. So this is using fetch. We're loading our data up, and we're starting to load the artwork for all the PNGs. If I completely empty the cache and run this again, you can see that one thing we're doing is if there's a lot of image content, it's loading all of it. Even though I'm only seeing like one of those or two of those on the screen, they all get loaded because there's no smart loading for the standard image tag. So keep that in mind as we're looking at this. And the code here, if we're looking at it, is just a plain old fetch in a use effect. All right, so if you're a React developer, all we're doing here is in our podcast component, we're pulling off of a Node.js server, we're pulling a REST call back, bringing it back as a response, turning it into JSON, and using the state hook to turn it into content that we just print out with a bunch of cards in a card container, just components I made up. I'm also using Tailwind CSS because I was lazy about my CSS design. Sorry, Drew Ducarme. Okay. So in that case, what we're doing is we're getting the entire React application. It's being downloaded and bootstrapped. And then we're issuing our network calls. Let's say we had two of them to do. One thing you have to think about is, can I do things in parallel, right? So in a standard React app, do I have to do call one to get the answer back to then do call two, in which case I've got a waterfall of calls one after the other? Or can I parallel kick them off and then basically as each one comes back, update the view? Either way works, depends on what you have to do. Bottom line is they both come back, they both update the DOM because the React component gets the answer and sets its state value, and that's it. Let's talk about doing the same thing, but doing it on the server side. All right, so we're rendering our art on the server. So we can do the same kind of thing. We can get the React page. And so let me just do that here in the browser and show you what happens. All right, bring this up. All right, so server rendering. If I look at the first thing that happens, I get the podcast back. But look at that response. Now, this is a React component, okay? But all the content is pre-rendered for me, ready to go, server-side rendering. So what happened was it went to the server, it hit this route, localhost 3002 SSR podcast, the 3002 is where Next.js is running here. It hit the podcast route. The server ran, fetched the data from my network resource. Actually, in this case, I'm using a database directly, and I'll talk about that. But it fetched the data. When it was done fetching the data, it put it into HTML content and shipped it back. Then there was a very short phase where it boots the application. So in here, if I look for JavaScript, there's the JavaScript. So in that first 200 milliseconds, the page is already there. I can actually see the content. The first content comes in. And now I'm booting React. And after React is booted, it starts being reactive. And it starts loading all the content for like the images and things like that. So do all. Now we see all of our images being loaded, for example. All right, so server rendering. There it is. So we get our calls on the server. They get the answers back. It sends back the data for us, renders the page. And then after it renders the delivered page content and boots the page, now we're interactive. So the call can take as long as the longest fetch in order to server render the content, right? So if, let's say our cloud resource server in Virginia is nice and close to our web server that's running Next. So that's relatively quick latency-wise. Maybe the data is quick to get, and that's fast. But if your server in Ohio also has to run before getting the answer back, and that's slower, then we're waiting on that. So that can cause the latency for that first paint of the content that's pre-rendered to be slower. So it's not like you can flip a switch and suddenly everything is faster. You have to think about these things and apply them the right way. Does it make sense to put them both together in one call? Can you basically do one that you really need right away and then do the other one from the client side later because it's less critical? Can you cache things on the servers to make them faster? Is your latency as bad as the client's latency because you're in different clouds or something like that? All right, so things to think about. One thing that Vercel recommends for Next.js, and also the Remix.run team recommends, is if you're going to do server-side rendering, where appropriate, especially where you have control over it, if you can deploy to edge servers, especially if you have a geographically dispersed set of people, if you deploy your app to different edge server locations, so you've got a web server and you've got your resources in the same co-located place, and you can replicate that data in, well, then it's going to be the fastest, least latent way of querying the data once you get to that Next.js server. So you hit get the page route, it runs the web server. Web server begins the Next.js calls through fetch to get the data. They both come back. They're close, co-located, and maybe you're querying with Postgres or Dynamo or whatever directly instead of going through REST. Come back quickly, it assembles the data in the page, and it renders it. It's not necessarily a cheap thing to do because you do have to pay for those edge networks. And also, if you think you have this problem but you haven't measured it, then you're pre-optimizing. So these are just things to think about. Do you really need to do an edge network if you're doing a small amount of calls with a small amount of data? Or if a ton of people are hitting that server, do I need to scale that thing up to be able to handle this kind of load? Here's the code in Next.js to support server-side rendering. So in a component, all right, so this would be the podcast's TSX TypeScript component in a directory called pages. So there's my component there. It's going to get a feeds prop. The way to load that feeds prop on the server side is you export a function called get server side props. Get server side props runs on the server, does whatever you want it to do to assemble the data you need to pass to props to the component. You'll notice the shape is very specific. It returns an object, and one of the properties of the object has to be props, and then it can be whatever named props you want to send it. So I'm going to send it a prop called feeds, and it's going to be the data that I fetched from an API that I have. It just so happens that API on my end is a Postgres client that calls directly into the database. So I'm not hitting a RESTful server because I don't need to, because I have access to the database. Then, once that's done, it will call and create the podcast component instance, passing it the feeds, and the rest of this is a regular function. So I'm just putting together a map and ultimately returning a collection wrapped in a container of these image cards. And so this happens, it's rendered on the server, shipped down to the client, as you saw in the example, as content, and then right on the heels of that, it bootstraps React for us. There's other props you can pass it as well. There's a not found prop where you can control how you deal with 404s. There's also a redirect prop if you want to redirect to another route instead of rendering a component. Now, what about that path issue, right? What if you have a path in your app? Like, so for example, I'm in SSR here and I pick a podcast. Let me just get rid of that. Pick a podcast. And I say, I want to see the AWS morning brief, okay? So I had to pass it a path piece, a slug. You can see I have a bug there, but ignore it. AWS morning brief is part of the path. And so my server-side rendering needs to get that parameter in order to properly do the query to render just the AWS morning brief podcast. There's a lot of show notes for these. So in that case, get server-side props can get a context property. And the context property has a request and a response property. It has a query property. The request and response are HTTP request and HTTP response for Node.js. And some other things, locales can be passed in here. There's a preview mode for previewing a page. But the one we're interested in here is the params one. And the params one, if you look at the name of the path I have up top here, we have /pages/podcast. So pages is a special folder for all of our page components. Podcast is the path I'm going for. And then I've got the slug. So the URL that we saw earlier was, I'm just putting SSR there because I have different versions of this. Podcast, AWS Morning Brief. This is the thing I call slug. Okay, it's a path-based parameter, which we're all used to with React Router and things like that. The way you would do this is you create the file name with brackets around the file. So slug.tsx, that now becomes the parameter name you can grab in the params object. So when you route to /pages/podcast/ whatever name, if I hit context.params.slug, it's that name. Now I can use that with my query, with my get feed and episodes by slug. I pass the slug to it, and I still have to return my props object. Whoops, sorry. My props object, and it's the data I fetched. From there, that data is two things, feed details and a collection of episodes in my code sample. And so I just destructure those props into the names I want, and I'm moving. Regular old React component from this point. So the thing to remember about Next.js is it basically hooks these things around a regular component, and it passes you props for server-side rendering. Now let's look at Remix.run. Basically operates the same way. If I go into my Remix demo, there's my Remix demo with stuff in it. If I go back to this mode and look at my network as I fetch, all right, there we go. So we got our podcast, and again, content. I think I might have limited the now. I didn't limit the number. Interesting. All right. Well, anyway, yeah. So the content all came in. A lot of this is wrapped. As I get further along, we're booting our JavaScript, loading things up. Server-side rendering. Okay. Same thing. So let's look at the code for it. Remix takes a slightly different approach. So what they do is they use hooks. They use a function and they use hooks. So the function is now called loader instead of get server-side props, just a different name. And in that one, you just return the properties. You don't have to create an object with props in it. Just return an object that has the props you want. The thing is, they're not going to come in as props, though. They're coming in from a hook called use loader data from Remix. So in your functional component, instead of like passing it in as a prop, you call use loader data, and it returns the data that it gets from the loader. Then you can do the same thing you've done before. You know, you go ahead and you map over your data for your collection, and you return your container with the collection in it. Just a little more collapsed. It's the same thing I'm doing in the other one. So again, the difference is you're using a function called loader. And by the way, I didn't mention async await for those who don't do it. The function is marked as async, so you can call await, and it will only return the value when the promise returns the result of the await. I am not showing error handling here, or it would be longer. You can do a try catch. Okay, so that's the main difference, a loader function, and then you use a hook called use loader data to get your data, and that's exactly what you return from the loader function. As before, if I click on a detail here, I'm getting a route with a parameter. There's not that many ways to do this, right? So now it's routes instead of pages in Remix.run. So that other one was routes podcasts. This one is a file called $slug.tsx. So instead of bracket slug bracket.tsx, they use a $sign. And so in that case, the way it works is your async loader function will be given a set of properties. So there's a request property, a response property, a couple of other things like context, which I don't want to get into here, and another one called params. That will be the name parameters of your route. So again, they both do the same thing. They just have slightly different names for doing the work, but they're doing basically the same operation. And now, same as before, we're going to get our feed and the episodes by that slug, by that name of that podcast. And then we use the use loader data just as before. We don't have to pass anything special to it. It's just the same thing. I've done something in a loader, give me the data from it. And we destructure it as before and get it done. Okay. and I just demoed it. So let's talk about some tips here, right? Again, it's not a magic bullet. You could be shifting a distributed performance problem that's spread across all of your users into a shared services bottleneck. Let's say that the web service that you're hitting is extremely slow. And it's slow because it was poorly written, not because it's behind a slow network. If you don't know that, and you say maybe it's just the network that's the problem, and you pre-select an optimization without really verifying where the problem is, you're just shifting the problem uphill to a server instead of doing it from every client. Also, let's say you say, okay, great, I just need one Node.js server. I just need one instance of Remix.run or Next.js because it's going to handle everything for me. It may not be able to handle a load as one instance. How many CPUs does it have? Node.js itself is single-threaded except for async operations, so you might overly constrain one node server and it won't be able to handle loads. So this is where you start talking about scaling and setting up multiple instances. Stuff you have to think about, maybe using PM2 or some sort of clustering or what have you, or running it in like a Kubernetes cluster with multiple nodes. So you're shifting to an infrastructural concern out of a distributed computing concern by putting something that might be really difficult to do with a lot of users at the same time in one CPU at a time. Just consider that. You can use Node.js database APIs. I mean, just to prove that out, if we look at the code that I have behind this, let's see here. If I go into my Next.js app and I look at my server-side rendered pages podcast, well, I'm calling get feeds, right? Get feeds, look at that, it's SQL. I'm just calling Postgres, and why not? This is like writing a Node.js server. It's like writing a writing like a Ruby on Rails server. It's just the front end's React, right? But the back end is still JavaScript, and it can still use things like fetch or whatever, but it can also use Postgres. So for example, I've got a little library that uses the PG library and imports all the props because it's on the server side. It can do that and does the work. Just plain old database calls. And that may be fast enough and faster, certainly, than going to a REST server that then has to pull things from a database into REST, serialize it across the network to my Remix or Next server, that then serialize it back down to the client, saying, did I leave the iron on? So monitor your CPU, monitor your load, monitor your network saturation, et cetera, and your memory usage, and scale appropriately. The next top is static site generation. So static site generation pre-renders page at build time. All right, so it generates statically rendered content when you build the application. And so I'll just show you that briefly. Let me just kill my engine here that I have for everything. All right. So to do this, I go into my packages and I go into my Next.js app. I should mention that this only exists in Next.js. They don't do this in Remix. So if I do a yarn start, it actually runs two commands for me. It runs a next command build and next command start. The build is going to take all the code, look through all the pages, and see which ones have the code to be pre-generated. And then it's going to go through and do that. And you'll see there's a different function I use for that. So now it's doing the generation of all the pages for each of the podcast episodes and such. And when it's done with that, it's going to run a server. I'm going to go back to the slides while this is doing its thing, and the page will just show up. So the render page downloads very quickly, and don't forget, I don't have to wait for it to render. It's already been rendered to a file, so I'm just statically serving that file. That's it. So it's a lot quicker to that first, byte of data, to that becoming interactive, because it has to wait less time. And then React bootstraps asynchronously. So how do we do this? Well, we do this with a function called get static props. So get server-side props is server-side rendering. Get static props is rendering at build time. You notice it still returns props, same basic mechanism, and they still end up being props being fed to the component. Now, something to think about is that if you have a million rows in your database that generate all of your props, well, I'll get to that. But actually, it's the next topic. I apologize. I kind of jumped ahead there. But anyway, beyond that, this is just props being fed to the component after at build time, figuring out what the data is for that given path. Let's see, is this loaded yet? Yep, it's loaded, and it gives you a lot of stats. Just show you the stats real quick. It's kind of neat to look at. You can see all the things that it built. So it knows how many things are server-side renders or static renders or statically generated. Interesting stuff there. But now I can hit this thing. And it's really, really fast. Let's go to one of these. Boom, instant, pretty much instant. It's all statically served from the server. So the faster the server is, the quicker it is. If there's a lot of content, that's why it took a while, because it was just rendering a lot of content. All right. So get static props runs first on the build. It gets the data it needs to feed the props of that particular page, and then it renders the component to disk for it to serve in production. If you're running in development, it renders it every time because it wants you to find bugs. So you have to build it and run it in production by using next start after doing next build in order to actually see this happen. Now, how about dynamic pathing for that? Well, if you have a slug page like we did, as we navigated to, right? We're looking at one of these here. You can give it a context object in the static props, but first you have to tell it how many variants of the path you have. So for example, you see this get static paths function you export as well. That runs first. That lets you query a database or a REST call or whatever, or load from whatever, and you bring back a collection of routes with the unique part of it. So the slug being different for each one. So I get all the slugs back. I then do a map, and I turn this into an array of objects, which has a params prop, and then any parameters I want to pass it. This get static paths then returns the paths property and other options, like, for example, fallback, whether you want to see a 404, or if it's been updated, you want to see a cached content, for example. You can say, if I don't find one, set this to blocking, fallback to blocking, and it does server-side rendering at runtime automatically for you. You can also pass out a revalidate property, which says this is how long this is valid before I have to do server-side rendering because it's stale. They also return a property in the response called X Next.js cache, which tells you what happened with any given request. All right. And so then with the path, we just have our get static props. Yeah, that's the same thing. And then I think I just put this in here for you just so you can see it better. So it's the same thing, really. Sorry. All right. So tips with dynamic routes, make sure you don't take a giant database of content and build 1 million routes, because your build time is going to be ridiculous. What you can do instead is build the top ones based on statistics that you can pull in your data, figure out the ones you always want to have generated and generate those, and fall back to dynamic server-side rendering by setting that fallback. And then you'll just render it the first time and cache it. All right, and that's that next incremental static regeneration. The other benefit you get out of this is you get SEO crawlable content, which is really good because the content's there when the search engine runs. You don't necessarily need to have React running to get that initial view. Then you can, if you want to, you can have SWR, the other library, after it's loaded, wake up and then get more up-to-date data if you'd like to. It's a little complex, but you can do that as well. Don't use SSG on time-sensitive data because it's time-sensitive. It's generated. So if it needs to be updated, then you have to figure out how to update it, and then you might as well just server-side render it. And also don't do it with user details because these things aren't meant to use for user details. The Remix team completely disavows this approach, by the way. They'd rather see this server-side rendering than SSG. I leave you a Twitter thread for you to research on your own to see their thoughts around that. They feel that, like, after a certain point, performance is worse with server-side generation on a dynamic page. The last thing we'll look at here, and we'll have a very brief thing after that, is client-side rendering. We've all hopefully done fetch, and fetch is a way of client-side rendering things in React by having the browser go into an AJAX call, a network call. This is a smart network call that can refresh based on whether the Chrome tab is visible and then goes invisible. When it goes back to visible again, it will automatically reload by default. It can stay after, let's say you say after a minute and a half, go and fetch it again. So you can have it automatically refetch. If the network goes out, by default, it reconnects, and then it says, oh, okay, based on the network being out, I've got to refetch my data to get it to be less stale. And to configure these things, you either pass them in as configuration parameters for the call, or there's a component you can mount around your components that use SWR that control these settings. And this comes from RFC 5861 on the web. SWR stands for stale while revalidate. It's a cache control extension of HTTP. And they want you to be able to use this to immediately return a stale response from like generated server stuff while it revalidates it with SWR in the background. Therefore, you get a quick first paint, you're interactive right away, and you get an update later after you become interactive. And so it looks a little bit like using fetch, except for the fact that you use a hook called use SWR instead, and it returns you at least 4 things. So the data, when it comes back, shows up in your component. If it's failed, the error shows up with your error code and information. Is validating is a Boolean that it's true when it's loading, so you know when you're loading. And then mutate lets you call a reload of the content manually for whatever reason. So for example, if there's an error, we return our error. That's a very cheesy example. If we're validating, we return a spinner, and then otherwise we go through and process our data. So we're comparing the two frameworks. You can see that Next.js is pretty mature in terms of all the features it has compared to Remix. Remix is a smaller core. They're really trying to make things simpler for the developer by using the same APIs you use in the browser. But the Remix side doesn't have as many features. It does have the router, and it does have server-side rendering, but it doesn't have its own smart fetch library. But you could technically use SWR on top of it if you'd like to. Coming in the next version of React is server components. So React 18 just was released. Next.js is all over this, and they really want to be able to release a stable version of this once it's all been kind of worked through. Right now, they're in alpha or preview mode. So if you're using server components in React, it's not really a production supported thing yet. So I think 18.1, 18.2, it's going to really be a live thing. You'll notice that a server component is imported with a .server at the end. Yes, there's also a .client to say this is always going to be downloaded to the client. And if one doesn't have a server or client, it's shared. It can run in either place. The other thing that you use to make these server components real is a suspense tag, a suspense component. The suspense component allows you to specify fallback markup, fallback JSX, while it's loading from the server side. And as soon as the props you need are loaded, it renders that particular content where the suspense was. The next team is trying to get this up and running. They've got some servers. In fact, I pointed a sample to you there in the notes. So you can take a look at this and download it. To me, it's still a bit confusing. It's not very clear how you would write the network calls. They didn't really document what they're doing yet. So it's in preview. Keep an eye on it. The one thing that's different about server components in React is they are completely HTML. When they get downloaded to the client, there's no interactivity once they're done. So it's like another feature on top of what we're already talking about. It's not ready yet, really. And that's the talk. So remember, Next.js and Remix are extending React to the server with various approaches. Their goals are to decrease latency, get you to that first render, get you to that point where you're interactive quicker. But it gives you the ability to break up your application and make it a little more modular by having routes for the different components that you can jump into. It loads them quickly up front. It lets you deploy to edge servers. There's some samples out there. If you look at Remix, they've got this thing called Remix. I forget the name of it, but they have stacks, Remix stacks, I think it's called. But they've got samples that'll run even on serverless, for example. And the same with Next.js. They got tons of samples for these. But beware of vendor lock-in by embracing these frameworks too early. and not considering all the angles, things like how much does it cost to run on Vercel? Can I run on AWS? Can I run standalone, et cetera? What your target platforms are and how to scale them. So just remember, this is not a bunch of switches you turn on to make it faster. These are just new techniques in new servers that you have access to. You can get to my sample code and slides. I'll put this information in the room chat. And if you have any questions, we can talk out in the hallway, or we can also talk on a separate channel if we have a lot of them. So sorry I ranted the entire time, but I'm definitely open to talk.
I actually think you have about 10 minutes left, right?
Whoa, beautiful.
Yeah, I know.
Better. I timed it for 50 minutes and I made 50 minutes. See that? Okay, do we have any questions?
I see someone typing right now.
Okay.
So we'll kind of give it a second here, and if there's none, then...
Yeah. Let me give you a 30-second tour while we're waiting for the question of the component samples I have. So this is just a good thing to get you started and playing around. What you're seeing here is this is the project. I've got the presentation inside the project as a PDF, and you'll see I'm using Yarn as my build tool. I shouldn't say build tool, it's my packaging tool, and I'm using Yarnberry, which is the modern version of that. And each of my projects are in a package. So there's a Docker container for the database. There's a feed loader to take an OPML file, which you can export from your podcast player and turn it into data in the database. And then there's a Next app, there's a Remix app, and a plain old Create React app to play with. Also a Node.js server that serves endpoints if you want to play with that, and some shared code. So anyway, that's all there for you up in that link. All right.
You got a good job, but there's still a few people typing. So, any guess on percentage of users on each platform?
I don't have one. I think the Next.js has, from what we've seen anyway, some of our clients have switched to it over the last year or two. So it seems to be the one that people are looking at. Mainly, they've got a hosting service available to them. You know, they're funded by that. Remix, I think, has a much smaller user base right now, but I guess I'll find out when I go to the conference if someone sees this and says, that's not true. But it's relatively new. It was open sourced like last year, I think. So, you know, just looking at the numbers on GitHub, it's, you know, smaller at the moment. But people who use it really like it. You know, they say it's less code overall to do the same thing. Okay. What Drew said, third-party component libraries are great for these demos. Sir, I don't have anything on performance metrics differences. You'll see there's a really good paper by the, it's kind of funny. Hold on a second. Remix.run versus Next.js, Ryan Florence. So Ryan Florence, who's one of the founders of Remix, has a kind of a detailed difference between the two that I will put in the chat on the Slack here, where he, of course, he has the Remix team. He does metrics, and what they did, they say they really like Next.js. So what they did is they tried as much as they could to do an objective opinion of the difference between the two in performance. That'll give you some information. There's more focusing on functionality than that for my talk, unfortunately.
I was going to say, Drew DeCarm asked you a question.
What was it? What do you like better after creating your examples? I like the fact that you have static site generation in Next.js, so I like the option, and I like some of the components they have in Next. But I'm kind of with you in that I'm intrigued by Remix because it looks like it's just, they're really working on optimizing it, making it simple. If I had to go with one tomorrow and I had a team that needed to do something that I know needed some server-side work, I'd probably look at Next.js as a contender for sure. Then again, you've worked with both too, so I'm kind of curious. Martin says, do you think this is all reaching a tipping point in terms of complexity? Yes. So this is a challenge because you're next rest of that. Do you think this is where people are headed, or will they start to seek simpler solutions and frameworks? This world reminds me of Enterprise Java Beans 1.0. That's how old I am. So it seems like we're moving 1,000 miles an hour And we're doing lots and lots of libraries and frameworks and tools. And for people that are really good at that, you can get a lot done. I'm intrigued by HTMLX, for example, or HTMX. If there's a way to do it simpler for people that maybe aren't experts in that and just want a light amount of functionality that's good enough for a mostly server-side but highly reactive front end, maybe something like that's better for a lot of people. But yeah, there's a lot to learn for sure. I've learned it. It takes investment. I've learned enough of it to feel like I can be more than dangerous with it. And I'm curious what Drew has to say, because Drew really does this every single day. He does a lot of this stuff. So I'm looking at Drew Dakar and see what he might be writing. And yes, EJB 1.0. My point being that, like, I felt like when I was writing EJB 1.0, how the hell would you even know how many instances of a bean you need to fire up? There weren't even profiling tools back then. Make it happen. That's why Spring was so useful, right? So these APIs aren't that onerous, but it's like, because they're specific to the vendor, I worry that we're kind of fragmenting off into a lot of different libraries out that are all doing the same thing but differently. So your choice of movement might be hampered by the fact that there's no standard around it. That's my concern. So I share that with you, Martin. Let's see what Drew said. They both have their opinionated abstractions. Remix aligns itself exactly to HTML standards, i.e. Next requires rehydration of React on the front end. Remix can run without any JS enabled. And that's something I really didn't spend enough time on. So if you have JS disabled, it's just sending content back and not booting React. So yeah, the whole graceful degradation down to just simple HTML is interesting to me. So yeah, oh yeah, let me put the, yes, it's all insanity. I agree with you. Let me put the link for the repository up there. All right, but thank you for attending. I appreciate it.
Thank you, Ken. This was awesome.
All right, you're welcome.